understand the background of that algorithm and how these particular algorithms helps us so as to perform the activities. So all these aspects, and I'll be giving you some sort of insight how we can make use of these machine learning algorithms and where do we use these kind of the algorithms. So that is the main idea. And before launching the KNN, a simple question, guys. Every machine learning developer should ask why learning? Because the first point, because always we are talking about the machine learning like that, and why we need to learn. So, what is the main reason behind the process of the learning? If I am considering this particular learning, friends, so this learning, okay, is basically used when human expertise doesn't exist. Okay, so friends, here the point is very important. Uh, if I'm talking about the expertise related to the human, maybe the domain knowledge, or else some kind of experience he's having, or maybe qualification, whichever, where there is no human expertise doesn't exist. Why we are learning the data bricks? Because we are having some projects and we are not having that much exposure on that Databricks. Of course, though individually we are having learning of Python and the Spark understanding, but we need to see how PySpark behaves and how Scala helps us. So those things where human expertise doesn't exist, there the learning will come into the picture. And one more interesting aspect, friends, here. So humans are unable to explain. Okay, this is well suited for every algorithm, friends. Okay, unable to explain their expertise. This is something like, while performing some kind of manual activities, whether the mail is spam or ham, I cannot convince the users based on my statistical methodologies or based on my understanding all these kind of things. Okay, so humans, though they are having the expertise, but they are unable to explain their expertise. And most importantly, guys, one more point. See here, solutions. Okay, whatever the solutions I'm having, change in time. So maybe at one time, if I'm applying the algorithm, or at one time, if I'm seeing some kind of thing, over the period of time, if the outcome is changing, then in that case also we need to learn. But maybe 2 years or 3 years back, it is enough to have SQL and Python. So now slowly we are moving to this PySpark as Databricks is gearing up and AWS kind of things. So, of course, earlier also they are there, but at least if we are considering our condition of projects and all those kind of things. And moreover, coming to these particular solutions, and these things should be adopted to particular cases. Okay, there are generalizations are there, specializations are there, but these things are adopted to a particular case. Now, overall, why we need to learn? Why learning comes to the picture? Human expertise doesn't exist. Humans are unable to explain their expertise, and solutions change in time. So, whatever the solutions we are working on, a bigger problems, if they are changing in time and adopted to particular cases. So now I am putting a small thing before landing on KNN. In that case, what is machine learning? Now, the perspective is a little different. Earlier, machine learning is a set of algorithms and which we can predict something, and we are going to dependent on some kind of the algorithms, and with the usage of the models, we are going to predict something. These are all vaguely we are having the idea about machine learning. But while talking about the KNN or certain kind of algorithms, we need to be very stringent. Okay, what exactly our expectation related to the machine learning? So here I'm not defining trends actually. I'm giving the perspective of the ML, and of course definition also we'll see. But before defining that, let me give what exactly the ML aspect. So getting the machines or computers to program themselves. And these points, why I am bringing up again is friends, there is a context actually. So after before closing up the session, definitely we can realize which are all, whether these points are really connecting the dots or not. And second thing is let the data, whatever the data we are having, do the work instead. Okay, let the data do the work instead. And finally, a very interesting point, guys, automating the automation. And many a times, just you may be seeing these kind of the terminologies in the blogs and all. And suppose I'm having the automation that I want to automate. Something like my algorithm is there and I want to convert that algorithm into the model. And these are all data pre-processing techniques are there, some metrics. As a whole, as a combination, we can see that as a data science kind of thing. And ML, of course, as a part of the data science, you can see that. So, as a whole, if I'm talking about the machine learning perspective, getting the computers to program themselves, let the data to do the work instead, and automating the automation. Now, if I strictly give the ML perspective or definition of that ML, okay, simple friends. Here, ML is an application of artificial intelligence. This is the basic point. And if someone asks you what do you mean by artificial intelligence, very simple and straightforward answer. Any activity that gives the machine to learn something, that is artificial intelligence. Maybe if you are feeding some program, or maybe you are using machine learning or deep learning, or whichever the act that make our systems smart. That is the act of the artificial intelligence, guys. Very simple narration. And that provides actually machine learning is a part of that artificial intelligence perspective that provides the machine or system the ability, okay, the ability. We are calling that as the ability to automatically, okay, learn and improve. See, friends, here learning already we have seen. Now we are talking about the improve from experience. This is the most important aspect from experience. And most exciting part is for developers of machine learning is without being okay explicitly programmed. See, friend, this is most useful part. A reason is even in case of CPP or Java, guys, you can implement this particular code or algorithm. But even in fact, some of the libraries, okay, Matplotlib or Cburn, they practically written in CPP, friends. Okay, so now the advantage of these particular things is that whenever I'm talking about the machine learning, without much code, without heavy code, what I can do is with the help of some algorithmic notations, with the help of some kind of the packages provided by the programming language, I can implement these activities of learning and improving the capacity or prediction rate from the experience without being explicitly programmed. So now we are having a pretty simple understanding of why we need to learn and what exactly the machine learning does. And here, apart from these things, what we are going to study is now we are in that part actually study of algorithms. Okay, now we are in the study of algorithms that improve. Okay, whatever the thing, our always our intention is to improve the performance, improve the performance. Okay, of at some task, whatever the task I'm talking, with some experience. Now everything is under frame. Okay, just we have defined learning and we have seen some kind of task with experience and all. And one more thing, friends, if I'm asking you, okay, as a kind of machine learning practitioner, which are all the challenges? Which are all the challenges? we are going to face while implementing these ML kind of the applications or models. Okay, of course, you can add in the chat window, friends. Out of interest of the time, I'm listing out a few points, and you are free to add whatever the challenges you faced, or you are assuming these things can be a challenge. Okay, you are free to use the chat window, guys. But initially, I'm posting some of the challenges here, mainly data files. Okay. So data comes in all shapes and sizes because we cannot predict whether the data is not neatly arranged in the CSV or Excel format or JSON. And it is the responsibility of the data engineer so as to work it out, and yeah, he or she should convert that thing which is really useful for our algorithmic support. Okay, and most importantly, pre-processing. Okay, maybe that is the missing value imputation and encoding, and that might be the feature scaling, whichever may be. Okay, and pre-processing. And one more thing, guys, here we need to observe the dimensionality reduction. So because this is the biggest challenge of any machine learning application, because the dimensions are really heavy dimensions we are going to get, but just like that, we cannot remove the dimensions. There are certain approaches are there, and sure, I will scope all those particular things according to the coverage. Okay, so definitely these things we are going to discuss, but initially we are starting with the challenges and all. Next thing is identifying a best model, because there is no code book or rule book to define a best model, and hyperparameter tuning. This is also one of the important aspects, friends. Okay, so now just if you observe the machine learning, automatically learning and improving the performance of a corresponding application. And here the real challenge is we are getting the data in many shapes and all the sizes, and how we need to handle the missing values and those kind of the encoding techniques, feature scaling. Again, the data is having many dimensions, and how we are going to reduce those kind of the dimensions, and finding out of the best model, and tuning of the appropriate parameters is also one of the barriers, one of the important challenge that every machine learning engineer generally face. Okay, and one more thing, just as a recap, guys, just definitely this is worthwhile to mention the kind of learning. Okay, in case of the machine learning, we are having supervised, where this particular supervised, again, I'm having the kind of the classification, and the second thing, of course, guys, the regression. Now, at the moment, I'm listing out the usage of this particular classification. We have seen that some kind of yes or no, true or false kind of the notions. Putting in a right way, just I'm giving this thing, the response variable. Okay, response variable is categorical, or else it may be discrete, guys. Okay, because we generally have continuous data, discrete data, and in the landscape of the machine learning or data engineering, we should use certain kind of the terms like response variable, predictor, all these kind of things. So if I'm working with the classification kind of things, our response variable must be categorical or discrete kind in nature. And like success or failure, or true or false, yes or no, either one or zero, all these kind of things. All these things belongs to the binary classifications. Okay, binary classification. But always the story is not end here, guys. Okay, so that is what you call a multi-class problems would be there in the classification. Maybe I can say positive or negative or neutral kind of thing. Okay, or else I want to find out. maybe some kind of technologies. Okay, multiple technologies are there. At least four technologies I want to list out. Then in that case also, the multi classification is playing a vital role. And kind of the applications. Okay, we are going to work out in the classification is generally guys customer churn count. Okay, how many members changed the corresponding network from Idea to Airtel or Geo or something like that. Those kind of things. And moreover, the sentiment analysis. Okay, whether the people are liking okay which party or how the sentiments of the people are there, all those kind of the applications, and as well as the disease prediction trends, especially in the medical domains, whether that particular person affected by a particular disease or not, with certain kind of the parameters. And most importantly, just we are having, as I'm listing out again, so as to notify, first is the KNN, of course, today's topic, and second is the naive base, which is especially helpful in the NLP kind of the techniques, and our logistic regression, okay, which is one more algorithm related to our categorical kind of the observation, and then decision trees we're having, and thereafter we're having support vector machine, and thereafter, see friends here, neural networks. These are also belongs to the classification methodologies. And then our favorite, which is Panacea for all the problems, which is the random forest. Okay. And thereafter, so gradient boosting. This is also which is really helping us so as to boost the performance of the algorithms. And one more thing, the gradient descent. Okay, this algorithm is generally used for the optimization. See, a variety of algorithms are there, friends, like starting from the KNN, naive Bayes, logistic regression, decision trees, support vector machine, neural network, random forest, gradient boosting, gradient descent. All these, of course, belongs to the classification techniques. And to notify the second category, which is the regression kind of thing, here, very simple, the response variable, whatever we are talking, is continuous in nature. Okay, continuous in nature. And of course, the examples, okay, predict the sales of a particular product. Okay, so how much sales, or else stock prices of a particular stock, house price prediction, and thereafter company growth, okay, growth rate of the company, and weather predictions, friends. Okay, so all these kind of things, okay, are really helping. These kind of applications can be implemented with the help of the regression. And to notify, just I'm having the simple linear regression, multiple linear regression, and of course, polynomial we have seen earlier, but of course, I will scope that also in the further discussions, polynomial regression. And thereafter, we are having many other things like stepwise is there. Stepwise is very specific because there I'm having the forward selection where I can make use of dynamically adding the attributes, or backward elimination. So unnecessary dimensions are there where I want to eliminate those kind of things. Then I should elect the stepwise regression. And most importantly, guys, this regularization and penalization is there. For that, I am having lasso and a ridge regression I am having. And thereafter, we are having this elastic net. See how many are there. So maybe generally we feel simple and multiple regression, and of course polynomial at times. But apart from these kind of things, we're having stepwise regression and lasso, ridge, and elastic net. Okay. So now let me start with the k nearest neighborhood. Of course, I'm not going into the unsupervised. Whenever the topic comes, then we'll discuss those particular things. Okay. So now, just if you refer k nearest neighbor. What do you mean? What is this k nearest neighbor, and how we are going to make use of this thing? Always, friends, while learning any algorithm, there is a maxim, some kind of the maxim or some kind of the statements, which can be simply explained like this. Okay, birds of a feather flock together. Okay, the persons who are having the same kind of interest group together in office, if you see in universities or in corridors or wherever you go, and even in theaters or whichever. So the people who are having like-minded or who are having the same kind of the properties or interest, because some common discussion should be there. No? So in even in our case also, as we want to discuss some points related to the machine learning and data science, we are here in the call, right? So similarly, birds of a feather flock together, and that means things are alike or likely to have properties that are alike, the same kind of the things. And here the approach is like this, friends. So the nearest neighbor, I'm talking about the nearest neighbor. That means just I want to identify the classifiers, because basically this belongs to the classification techniques which are defined. Okay, basically which are defined by their characteristics actually. Okay, I'll show you how we are going to perform by their characteristics of classifying the okay unlabeled examples. Suppose I'm having some set of the examples and I want to classify a new label into the existing classes just by assigning. Okay, I want to assign them to the class of most simple examples. Uh, Most similar kind of the example. Now you observe here, friends, the analogy behind this k nearest neighborhood. And let me put a diagram here, so where you can easily refer. So this particular diagram really helps us to observe, to understand the process of the nearest neighborhood. Okay, so actually this particular nearest neighborhood is a simple algorithm where I can say this is a kind of the algorithm which allows us so as to notify or so as to observe the appropriate context, like whatever the orientation we're having. Just you see here this particular diagram, and here I want to classify this new set, new data item, and of course these are all multiple entries. Okay, and I need to check whether this particular new entry belongs to which class of. Actually, I'm having three classes, three classifiers, and I am entering a new entry or new whatever the input I'm giving, and I need to check whether this particular new entry belongs to which class. Okay, so what is the approach we follow, friend? Generally, what is the approach we follow? Suppose I'm asking you five, and I'm giving some kind of the numbers 3, 4, 10, 20. Now, if I'm asking you, where do I place this particular five? Obviously, you say that, okay, because 3, 4, and in this group, if you are placing, then it is same class. Whereas if I am giving some 25, then it is very simple to mention that 10, 20, and 25, at least these two. That means we need to observe some kind of the distance calculation. It's a purely a mathematical kind of thing, guys. Whatever the new value I'm having, and I need to compare with the existing values, existing value 1, existing value 2, and up to existing value n. Okay, now based on the distance, okay, based on the distance, I should see that the new entry, which is similar to the existing group. Okay, such kind of process is known as k nearest neighborhood. Okay, and now you may be seeing some kind of the terminologies like instance based learning. Okay, and sometimes we can say this is a lazy learning kind of thing. And we are also having the non parametric. Okay, all these three things are nothing but KNN alternative names. Instance-based learning, why we are saying is, suppose if I am making use of these kind of instances, because existing instances we're using, so as to validate which class, okay, existing class 1, class 2, class 3, like that I'm having classifiers, and I'm making use of some comparisons. So just this new value will be compared with the existing ones, and based on the distance measure, okay, whichever the value we are getting as a part of the distance, and the nearest, okay, set or nearest classifier that belongs to the new value can be placed into that group. If you see this example of rebate. So here the point is, just we are comparing the new value with existing values, instance 1, instance 2, like that instance n. So this is also known as instance-based learning. Similarly, the lazy learning in the sense, guys, it is like it is not learning anything. To be frank, our algorithm is not learning anything. It is just computing. It is computing the distance, and based on that particular distance, what it is saying, just it is giving the outcome. Let me give you this example. Suppose a person got 1000 to 2000 rank in home state quota of JEE, assume that. And maybe definitely, if he belongs to TN, and there is a chance of getting NIT Trichy, because in between 1000 to 2000, definitely CSC he may get. Suppose if the person get 2000 to 4000 rank in JEE, then he may be getting some ECE, because based on the distance, based on the competition, and maybe 4000 to 5000, we may be getting triple E. Okay, likewise. Similarly, other state candidate, though he is getting 1000 to 2000, he may be placed in ECU only, because CSC seats maybe by 500, because top most NIT, no? NIT Trichy means top most. So obviously by 500, the other state CSC quota would be completed or occupied. So definitely the guy, though he is having the 1000 to 2000, but still uh, he is not belongs to the home state. So obviously he will be placed into the next to preference group, ECU. So here the distance calculation is similar to this thing, friends. Okay. And moreover, if you want to go with the statistical, purely understanding of the statistical things, there are certain measures, friends, actually. So distance measures, um, those particular distance measures are like Euclidean distance, okay, and Manhattan distance, all these kind of the distances. Because if you are talking about the KNN, KNN helps us to verify or to specify which are all the entries. Okay, already existing entries are there, and what is the similar range of those kind of entries, like how we have seen our example. And there are certain distance measure, friends. One is the Euclidean distance. Okay, this is something like calculating the distance measure. Second is the Hamming code. With the Hamming code measure, you can see. Next is the Manhattan distance code. And at times, you might have seen this cosine distance calculation also, especially if you are working with the natural language processing kind of the application. So, either of these particular distance measure can be used in KNN so as to notify whether this new entry belongs to classifier 1, 2, or classifier N. So this is the understanding behind the usage of the K nearest neighborhood. Okay, and you may be having some doubt. Then without knowing the statistics or without knowing the mathematical functionality, how do I observe the distance? Yeah, I'm coming to that point. Let me pick up some code for you guys. Just a minute. So I'm fetching some code for you, and that particular code helps us to as to observe. Okay, so how we are making use of this particular KNN in our applications. Now, if you see this particular code, simply, okay, I have taken some kind of example. Now you observe, guys. So directly, what I'm doing here is, of course, I'm purely using the Python orientation. Okay, and slowly we'll see the PySpark MLlib also, guys. Okay, but however, the SKLN directly I can make use with PySpark orientation also. So just I'm trying to give you the understanding of how the algorithm or how the model, without doing any statistical measures, how a programmer or how a developer of the machine learning can make use of this particular model. Okay. Now, I want to make use of the k neighbors classifier. I decided that okay, for this particular kind of the application, the k nearest neighbor is the best classifier. So I'm having some sklearn, which is a famous library, scikit-learn, and within that the subclass is the neighbors, and within that neighbors I'm having this k neighbors classifier. Now already some Irish data set I'm having, so I thought of making use of that existing data set and NumPy, of course. This NumPy, Pandas, Matplotlib, and sklearn, Seaborn, all these are the most commonly used kind of the libraries by any machine learning engineer. Okay, so definitely we have to import those kind of things to perform some numerical kind of the calculations related to the array usage. Now, Irish is a famous data set. Just I am directly loading the things. Now, the point is, in case of the KNN guys, identification of the K value, which is most important. K value in the sense, see here, let me put in this way. What I'm doing here is I'm having classifier one with five examples, classifier two with three examples, classifier three with two examples. Now I want to estimate the prediction 11th classifier. This 11th value is there now, that I want to place in either of these classes because total I'm having three classes. My aim is to put the 11th one nearest to the corresponding classifier. In that particular case, guys, suppose if I am taking the k value as 10, I have taken the k value as maximum because all I'm having 10 values, 10 instances I'm having. That's what I can say that is the instance based learning. And I'm putting the 10 value, k value as 10. This is one scenario. Whereas I'm putting k value as very small. Now, what is the problem if I'm keeping k value as maximum, friends? If I'm keeping k value as maximum, then simply it is a biased result. Okay, so because already I'm having 5, okay, very nearest value automatically it keeps. Then automatically without setting to the medium values or less values, the algorithm is biased. Okay, and if I'm giving the lowest value and we cannot rely on the result. Okay, there is no reliability. So one simple thing, friends. So suppose n numbers are there. Okay, maybe the 100 instances or 200 instances or 1000 instances. Always better to keep value as a root of n. Okay, the square root of n. So suppose in this example I'm having 10. So nearest, okay, 3, I can put k value as 3, which is the optimized one. Okay. Likewise, what you can do is whatever the values I'm having. So here, maybe I'm having some 36 or something like that entries. So I have put that square root of 36. Automatically, will be getting that 6 value. Now, here at any point, we have not mentioned any kind of the distance measurements. Automatically, the k neighbors classifier inbuilt, it will take care about those things. And of course, explicitly, if you want to maintain the distance, you are okay to do that because in case of hyperparameter tuning, and especially if you are using NLP kind of the problem statement, and if you want to use KNN to implement that NLP, and best measure is cosine. Of course, as a developer of machine learning, you are free to specify that. But of course, without specifying the distance also, by default, the k nearest neighbor is having the capacity of deciding. That is what actually the algorithm is having certain default values, and based on that particular thing, it is going to pick up this KNN, and then we are putting this data and all these kind of things. Okay, and moreover, one more point I want to notify. So here the implementation part is okay, but the other aspect is there are certain measure trends actually. Like I need to predict something and I want to scope all these kind of the possibilities. Then there is a kind of usage like this. Suppose I want to predict some new value. there is a certain state, there are certain statements, like let me keep those kind of statements here so that you can easily get the point. So now if you observe this aspect, friends, okay, prediction, already KNN, we are having the value, KNN, K nearest neighbor with neighbors of 6. And now KNN, I can make use of as a kind of the model. And here prediction, actually fitting of the model and prediction of the model. Okay, if you see the fitting of the model, which are all the parameters we are taking. So just I am taking the data and I want to observe the target. Maybe Irish, if you are talking about Setosa and Virginia, like that, we're having some kind of target values. Now I'm giving some data, and my KNN should observe that whether this data belongs to which category. Okay, definitely this is a multi-class classification. So because 3 or 4 categories are there in that particular Irish data set. Now the prediction, okay, so there is a difference between fit and as well as the prediction, guys. Fitting is nothing but your model fitting. Prediction is something like, suppose if I'm giving the new data item and it should give me the category or the classification which it belongs. Okay, so that is the distinction how you can make use of this particular prediction and as well as the distinction between prediction and as well as the identification of the suitable target. And to before closing the discussion, just I want to mention which are all the hyperparameter techniques available. Out of that, I'm having this grid set CV frames, which is very, very useful for us. And of course, this particular code I want to portray. Okay, just have a look on this. We'll try to understand this particular code. In the earlier example, directly we have used this k neighbors, and now what we are doing is there are certain aspects with respect to model selection. As I said, the model selection is one of the important challenge. Okay, selection of the best model and all. For that, the researchers given this grid set CV. Okay, the grid set CV is something like, guys. Suppose I am unable to verify the k value because if k value is very large, then my result is biased, and if k value is very less, I cannot get the reliable answer. So now I am unable to decide whether I should go with the which value. Okay, sometimes even the square root also may not give me the, because 1,000 square root again it gives some 100 or something like that. And putting that those many comparisons also won't give any betterment to our model. So in that case, the refined version of this grid set CV helping us. So of course the process is similar up to this, just the same kind of thing. And now this particular parameter grid, what it does is just you see here, guys. Okay, just a simple narration. We are expecting, okay, some kind of the array generation. Okay, arrange, arrange which is generating the array 1 to 50, and this numpy which is assigning the neighbor values. Now, what it does is it just verifies and compares whatever the best value. Okay, whatever the best value we are getting out of this particular grid set CV, and with that value only, it is going to give us the best fit. Okay, and user need not worry about, whatever the values, and he need not go by the brute force kind of things and all. A grid set CV, see friends here, KNN is the first algorithm, which is of course instance based learning, and really there is no learning. Only depending on the distance measures only, it is going to compute the things. Now the point here is for KNN itself, if you are making use of the grid set CV, definitely you can expect the betterment. Okay, rather than you, at least in case of the timing, at least to avoid that particular brute force kind of specification, or always giving some kind of trial and error method kind of the input values. So just you can right away, dependent on these grid set CV, you need not worry about the best fit or best parameters or best score related to this particular KNN. And before closing the discussion, so just let me give you the KNN pros and cons, because I should clear that in which are all the cases the KNN is suitable or better. So of course, friends, it is very simple. and effective method because it is not having much computings. Internally, it is dependent on the distance measures. And one more important point, guys, here there are no assumptions actually. If I'm talking about the regression analysis and all, I may be having some kind of the assumptions, but KNN is purely on the mathematical computing. And most important thing is training process is faster, friends. If you compare with any other algorithm, training process is very fast. And similarly, this is not only the story, and of course, the downfalls are also there. Okay, the cons are nothing but if my instances are more than it is computationally expensive. Okay, because I have to compute the distance measures for every thing. This is very expensive business, especially if I'm talking about the model preparation with the help of the KNN. And moreover, memory wise also it's not that great, guys. Stores all training data because it has to. It has to store. Otherwise, there is no point of getting the distance values in a better way. And obviously, as a byproduct, we need to assign it is demanding high memory. And most dangerous thing is it is sensitive to the outlier trends. Okay, remaining things we can manage. Okay, with the of course making some kind of the grid set CV or making some sort of techniques, deep data pre-processing or something. But if your data is containing the outliers, so you should be very cautious to handle the outlier kind of the things. Okay. So, and maybe one final conclusion I can give on which are all the applications. Okay, where I can prefer the KNN kind of thing. Let me list out. Especially guys in the credit rankings, generally the various CIBIL scores and all, they elect this kind of KNN and customer churn analysis. Okay, so that's what we are usually getting if you change from one network to another network or something like that. And one more important application, guys, actually loan bankruptcy. Okay, based on the behavior of the customer or based on the behavior of the client, the organization should able to verify whether he is going to whether that company is going to bankruptcy or something like that. And most importantly, guys, if you see the optical character recognition. Okay, if you see this kind of the example OCR, used to call that. Optical character recognition is something like which is a distance measure. So for that KNN is best suitable. And most importantly, the image recognition based on the pixel, all these kind of things. Just you can make use of the convention. Okay. So just this is a small essence of KNN. Of course, I want to notify you with the usage of the KNN and all these kind of the parametric techniques and without any assumption how it is performing. Okay, so this is how you can see the KNN orientation. Okay, I'm stopping here. So just if you're having any doubt, please let me know. Yes. So if you are having any doubt later
Uh,
point of time, yeah, go ahead. Is that?
yeah, no doubts, Pawan. So thanks for making it
Yeah.
simple. Yeah, so I'm
Yeah.
good. I'm good from my end. Yeah, so yeah,
Okay, very good. Thank you. And maybe just a later point of time also, if you people are having any doubt or any clarification, please contact me so that I can clarify. You need not
Ye-
wait for until next week or something.
yeah,
Okay.
definitely we'll reach out to you. Yeah,
Yeah, yeah. Okay. Thank you. Thank you, guys. Okay.
thank you.
Thank you for Himanshu,
Thank
Krishna,
you.
and Deepika. Bye. Yeah.
Bye bye.
Thank you, Dr.
Thank you.
Bam.
Thank
See
you.
you.
Yeah,
Have a
yeah.
good evening.